The sun produces more power than we are ever likely to learn how to consume, and it will continue to do so for another 5 billion years, but getting that energy into our power grid is tricky. The sun is about 93 million miles away from Earth, and the scraps of highly diffused waves that make their way to us are further diluted by the atmosphere. By the time they reach the surface, we're dealing with a fraction of the power we could be absorbing if we could just reduce the distance between solar power collectors and the sun. So the logical solution is to put our solar power collectors outside of Earth's atmosphere, and we've been using solar panels to power spacecraft since 1958, so it's not as if we don't know how to harness solar energy in space. The trouble is getting it back to Earth. And after decades of flawed attempts, the Japan Aerospace Exploration Agency (JAXA) may be very close to figuring out how. JAXA's own explanation for the Space Solar Power Systems (SSPS) initiative explains the degree to which our natural world is already solar-powered, and efforts the agency is making to replace fossil fuels with this clean and renewable energy source. There have been various attempts to solve the space-to-Earth energy transfer problem, ranging from lasers, too hard to aim, to space elevators, too expensive. The most recent, and fully realized, version of the JAXA proposal was outlined by Susumu Sasaki in a recent issue of the IEEE Spectrum. It calls for an island of microwave receivers aligned with a satellite 22,000 miles away, beaming the intense but probably harmless microwaves from the satellite to Earth. The proof-of-concept version of the SSPS will launch in 2020 and provide 200 kilowatts of power. The hope is that by 2040, the SSPS will beam 1 gigawatt of power back to Earth. It's still not enough to provide all of Japan's power needs, much less the world's, but it would be a legitimate power plant, and would mean larger and more powerful satellites could soon follow.